Hi guys, welcome to Finite Mathematics 1 under the Strengthened Senior High School Curriculum. And our first lesson for today is Symmetry in Nature and Art. Mathematics is not only about computation, it also involves recognizing patterns and relationships. Symmetry highlights this idea because it connects logic with creativity. When we observe natural objects such as flowers, snowflakes, or even the human body, we can notice patterns that follow certain rules. The same is true in art and architecture, where symmetry is often used to create balance and harmony. This shows that mathematics is not only something we solve, it is also something we observe. Symmetry means that a figure looks the same even after undergoing a transformation. These transformations include folding, rotating, or sliding. In simpler terms, if you change the position or orientation of an object and it still appears unchanged, then the object has symmetry. This idea allows us to classify and analyze patterns based on how they behave when they are moved or transformed. A well known example of symmetry is the Taj Mahal. If we draw an imaginary vertical line at the center of a structure, the left and the right sides closely match each other. This type of balance is not accidental. Symmetry is often intentionally used in architecture because it creates a sense of stability, order, and aesthetic appeal. This is why many famous buildings and artworks rely on symmetrical designs. There are three main types of symmetry: reflectional symmetry, rotational symmetry, and translational symmetry. Each type describes a different way in which a figure can remain unchanged even after being transformed. Reflectional symmetry, also known as mirror or bilateral symmetry, occurs when a figure can be divided into two identical halves that are mirror images of each other. The line that divides the figure is called the line of symmetry. This line acts like a mirror, where one side reflects the other. For a figure to be symmetrical, both halves must match perfectly in size, shape, and position when folded along the line of symmetry. It is important to note that not all divisions create symmetry. A shape may be split into two parts, but if the two sides are not exact mirror images, then the figure does not have reflectional symmetry. Rotational symmetry occurs when a figure can be rotated around a fixed point and still look the same before completing a full 360-degree turn. The fixed point around which the figure rotates is called the center of rotation. To better understand this, we consider the order of symmetry. The order refers to how many times a figure matches itself during one complete rotation of 360 degrees. For example, if a figure matches itself 5 times, then it has an order of 5. Another important concept is the angle of rotation. This is the smallest angle through which the figure can be rotated so that it appears the same again. The angle of rotation can be found by dividing 360 degrees by the order of symmetry. If a figure has an order of 1, it means that it only matches itself after a full 360-degree rotation. In this case, the figure is considered to have no rotational symmetry. Some example of rotational symmetry in real life would be the windmill, which keeps rotating and the shape remains the same. You can see the same shape while it is still or moving. A fan also falls in the category of rotational symmetry. It shows equal parts even while it is moving. Translational symmetry occurs when a pattern repeats itself as it is moved or slid in a straight line. Unlike reflection and rotation, this type of symmetry does not involve flipping or turning. Instead, the entire figure is shifted in one direction while maintaining the same orientation. This type of symmetry is commonly seen in repeating patterns such as brick walls, floor tiles, and wallpaper designs. It is important to understand that translational symmetry applies to patterns rather than individual objects. The repetition must continue consistently in a specific direction for the symmetry to be observed. So, what do we call objects or things that do not have symmetry? We call them asymmetry. A figure is considered asymmetrical if it does not remain the same after reflection, rotation, or translation. In many cases, natural objects are not perfectly symmetrical. While some may appear balanced, closer observation often reveals small differences. Asymmetry does not necessarily mean something is irregular or disorganized. In fact, asymmetry can also contribute to uniqueness and visual interest. So, to summarize, symmetry describes how a figure remains unchanged after certain transformations. By understanding these types of symmetry, we were able to recognize patterns not only in mathematics but also in the world around us. Symmetry allows us to see the connection between mathematics, nature, and art. It helps explain why certain patterns appear balanced and why they are visually appealing. As you observe your surroundings, try to identify objects or designs that exhibit symmetry and determine what type they represent. That concludes our lesson. Thank you for listening.